Okay, so again, I'm going to assume you have the piece of paper in front of you. Some people are still shuffling, that's fine. All you need is this paper for now because you'll have more time, plenty of time to take out your assignment piece. Okay. While you're shuffling, I hope you can listen in. I'm going to read the question for you. There is a typo. The textbook gave an interesting number that essentially makes the calculation a little too hard and outside of what I intend. I'm going to ask everyone to change the 10 meters into 11.25. And the decimal seems like it's unnecessary or a little daunting, but it actually helps us a lot. So just trust me on this one. Okay. Water from a hose is sprayed on a fire burning at a height of 11.25 meters up the side of a wall. Before we go any further, if you follow the trajectory of the water, it gets shot up, but thanks to gravity, it will come back down. Should sort of look a little familiar to you. Okay. If the function h of x models the height of the water, okay, how far back does the firefighter have to stand in order to put out the fire? So I am going to assume, this is my firefighter. I give him the little hat, okay? And it's going to have a little hose, gotta give him the hose. And it's going to shoot up into the water, shoot up the water into the air. And of course, thanks to gravity, it's going to fall back down. I am going to, again, assume this is where the fire is on the top of the building, okay? And that height is going to be 11.25 meters. Good morning. Right? That's what I'm going to assume. Now, even if you didn't have this drawing, that's okay. Let's pretend it's not even there yet, right? Who cares? What does the math tell you? Well, the function h of x equals negative 0.15 x squared plus 3x. X is the horizontal distance. So again, if this was a person, x is the horizontal distance between the person and the fire. And the height is h of x. Read that carefully. It says the fire is up at a height of 11.25. It also says h of x is the height of the water. We want the water to go to the fire. So what we can automatically assume is that the height of the water has to reach the fire. Right? This is where the fire is. So this is where the fire is. This is what the water is. We're gonna have to assume that they're gonna equal. That sort of makes sense logically, right? But that is something that you have to draw out from the story. So let's continue. We know that h of x has to be 11.25. I also know that the equation itself is equal to negative 0.15 x squared plus 3x. How far back does the firefighter have to be? In other words, what is x? What's that horizontal distance? So if you know the question is asking what's x, let's take a look at it mathematically. Here's an equation. I want to know what x value makes 11.25. But instead of trying every single number you know in the entire number line, that's a waste of your time and waste of your energy, there's another way to solve quadratics. And that's what we've been practicing for the past almost a month now, right? You set one side to equal a 0, which means I have to subtract 11.25 from both sides. This becomes okay. Oh, Michael, one thing, this is a question from yesterday. I'm looking at the bottom example right now. It's in front if you lost it. 11.25, I need everyone to make an edit of that because otherwise. Okay, so looking at this, again, it should look familiar. You need to factor. So let's do so. I'm going to move this down to have some more space. But that number in front, that 11, so that 0 equals 0, negative 0.15 seems a little annoying. And the reason why I gave you 11.25 is so that I could do this. I am going to check if I could factor out that number in front. Because if I do, all of a sudden it becomes a simple trinomial. So negative 0.15 divided by negative 0.15 is a 1, right? 3 divided by negative 0.15, you plug that into the calculator, I believe you get negative 20x. And negative 11.25 divided by a negative 0.15, I think you get a positive 80. Let me just triple check. Oh, no, 75, sorry. Okay. So we're good. That's a 0. That's a 0. I need two numbers that will multiply to a positive 75, but add to a negative 20. I'm going to wait on you for this one. I think you can figure it out. Yes. Right on. Not just 5 and 15, the negative 5 and negative 15, which means the two values must be 5 and 15. So x could equal a 5 and x could equal a 15. What? Wait a minute. We're talking about water here. How do we get two numbers? Are there any numbers I could reject? A distance of 5. Well, that makes sense. Like logically, I could have a positive distance of 5. I could have a positive distance of 15. How the heck do I have two numbers? How does that make any sense? Yeah.
It could be because that's, I need to figure out how to explain this first. The arc of the water.
Mm-hmm.
Like, in terms of the graph, that could be like on the fire would be.
That's, you know what? Stop right there. Let's start there. Okay. We set our height to 11.25. So let's pretend my height is 11.25. If we pretend this water is a parabola, well, how many times does my parabola hit that dotted line? Twice, right? In other words, I could set it up so the water hits the fire on its way up. That would be 5 meters away. Or I could walk away and set it up so that the water hits the fire on the way down, which is 15 meters away. You know what I mean? So it makes sense mathematically that I should have two numbers. I could have, so I'll just fix it. The fire could have been here, and I stay really close to the building, right? Or I could have the fire here, and I stay really far away from the building. it makes sense, right? So it's not a mistake that there could be two different values. And there you are, right? So therefore, firefighter could be, the firefighter could step 5 meters or 15 meters away from the building, right? Where we assume that's where the fire is. That's it. So there's a logical application to these questions, and I hope that you will, yeah, trust your math. Even if you didn't expect it, it might reveal some interesting things about the scenario. Okay, so with that said, let me pause this because we're going to move on to our catapult assignment.